Hello everyone, I hope you're all staying safe out there and this very strange year has been relatively kind to you. First of all, I want to thank you for attending my session here at Past Virtual Summit 2020. I was really looking forward to being there in person for the first time in a couple of years, but obviously COVID-19 had different plans, and here we are. So this particular session is about the good, the bad, and ugly of migrating SQL Server to one of the public clouds. One of the reasons I wanted to do this talk is because we have a lot of customers that have done this. There are certainly some gotchas to it. And I want to give you guys some real world experiences of what I've gone through, what some of my customers have gone through, and some of my colleagues have gone through, and give you some sort of best practices and gotchas of how to really achieve this and be successful in the cloud. Given that we have an hour, it's going to be more wide than deep, but let's get started. Obviously, with Past, there's a lot that you can do, so you can click on all the stuff. You've probably seen the slide a million times. Just as an aside, my personal take on this is that as a speaker, the only way I can improve my session, what have you, is if you give us some feedback. I can take criticism, so I appreciate good, bad, and ugly, kind of like the title of my session. But please be constructive. That way, you know, if something is messed up or wrong or you didn't like it, that's the only way I can improve it. But just giving any speaker low marks just because you feel like giving them low marks doesn't let us improve. But if you loved it, obviously give me all top marks, but let's move on. A quick introduction about myself. Some of you may know who I am. I never assume that people do. My name is Allan Hirt. I've been working with SQL Server since 1992. It's been a long time. I interned at Sybase while I was in college here in the Massachusetts area, and not only did I wind up staying, but I interned there for a couple years, and that sent me down my database journey. I've traveled the world. I've worked with customers to do training. I've spoken all over the world, everywhere from Asia and Australia to Europe, and obviously here in the States. The thing I'm most known for is the SQL Server availability stuff, of which I have another session here on availability groups and virtualization. But I also do a lot of consolidation, virtualization, obviously more infrastructure focused is the topic of this one. Dual Microsoft MVP, meaning I have two awards, one on the Windows side, which is that cloud and data center management, specifically the high availability category. I'm a data platform MVP, which is also a SQL Server MVP, and a VMware vExpert. So I really do talk the talk and walk the walk with my customers. I'm not just technical and I'm not just high level. There's one of the reasons I love to do sessions like this is because I can take my real world experience and give it to you guys. Here's what we're going to be covering in the next hour or so. First of all, I'm going to go over some basics, some foundational things that will underlie all the other things. We're going to talk about infrastructure as a service as well as platform as a service. We'll talk about migration because that's sort of the core of this talk, but it's all related, right? And finally, we'll cover availability and what that means in the cloud. What's available to you? What do you have to think about? First of all, many of you know my rants about always on availability groups and proper terminology. It's not just availability groups. I also do it in a lot of realms, and this is another one. You will rarely, if ever, find me just saying the cloud. Because what does the cloud mean? There are really a couple different concepts with cloud. There's a public cloud, and that's really what we're focusing on in this talk. That's Azure, that's AWS, that's GCP, any other cloud provider that is not your data center could probably be called a cloud. I'm not talking colo, I'm talking something more like that's set up like an Azure or an AWS or a GCP. That's public cloud. Then there's a concept of a private cloud, which historically in my book means more like, kind of like the self-service stuff. It's not just having servers in your infrastructure. It's sort of having an end-to-end service delivery that, in a way, kind of mirrors what a lot of the public clouds do. But really what private cloud is about is that you don't have any shared resources with anyone. It's sort of a very closed-in, very secure view of the world. So you're not using any public shared stuff, right? So private cloud to me is something very different. The one thing I always tell all my customers, and sometimes it sticks and sometimes doesn't, is that when you're starting to think about going to any cloud, or even if you're using somebody's colo, for example, if it was on-premises, sort of similar concepts, you have to treat it as an extension of what you're doing on-premises. Even if all your servers are going to move up to an Azure or an AWS or a GCP, you've got to get your desktops talking up there, right? So everything becomes an extension of what you do on-premises. The cloud is the cloud, right? So you really have to think about this, and it's a mindset of you're extending what you do somewhere else. The other thing that, and I have conversations with all the time with folks, is that you can't just move SQL Server and databases to a cloud provider. Now, technically you could, but the reality is if you're doing infrastructure as a service, you might need other core bits of infrastructure up in whatever your cloud provider of choice is. So do you have to move Active Directory domain services? What about DNS? All these things need to be thought through. I'm focusing on SQL Server in this talk, but just understand it's a whole ecosystem you have to worry about. It's not just, oh, let's migrate from on-premises to a public cloud, and that's that. I'm not going to really read this slide, and you can come back and look at the deck on your own, but here's sort of how the three biggies map to each other and what they call certain things. And this will hopefully help you, because if you're jumping into the cloud space, you can't just say X, and then if somebody's familiar with Azure, they may have no idea what you're talking about. Reality is, the concepts here are all the same. For example, infrastructure as a service. Infrastructure as a service is basically just a virtual machine. Not basically, it is a virtual machine. So it's an OS where you would install SQL Server, and you'd manage parts of it. Maybe you'd automate or let Azure or AWS or whatever manage other parts of it. But it's more traditional, whereas you have platform as a service, which is, you don't get an OS, you get databases, you maybe get something that looks like an instance of SQL Server, but it's not, you're not getting access to Windows, you're not getting to tweak that stuff. You get the point, right? But these are the different offerings, sort of what they are in the different clouds. When we're talking about IaaS versus PaaS, really what we're talking about is choice. On premises, you're, sort of as I was saying, you're deploying an OS, be it Linux or Windows, for SQL Server. So you're managing everything. Whether you're physical or virtual, that doesn't matter. So you're choosing to basically kind of do what you do today, or PaaS, which is a newer version of the world, where basically you're managing your data in your databases. A lot of things, a lot of knobs that you have in a traditional SQL Server implementation wouldn't necessarily be available to you with, say, Azure SQL Managed Instance or RDS in AWS. So you really have to think about this, right? And this is sort of the promise of the cloud versus the reality of the cloud. It's trade-offs. So you need to think about, when you're going to a cloud or considering going to a cloud, what is it you want to do? Are you looking to basically do lift and shift? And we're going to talk about lift and shift more so when we talk about migration. Is it or is it not a good idea? Or are you looking to modernize your applications and use the cloud in the way it probably is intended to be used? So let's kind of look at what deployments look like at a 30,000 foot view. on-premises, you've either got physical servers or virtualized servers. Maybe you're running VMware, maybe you're running Hyper-V. There's obviously the public cloud we've talked about, IaaS and PaaS. So in the equivalents, again, IaaS is more like those physical or virtual servers, PaaS is not. The thing that I want to drill home here is that there's another in-between concept. It's not just on-premises and it's not just public cloud. There's this in-between concept called hybrid. Now, hybrid really is maybe some of your infrastructure's on-premises, some of it's in the cloud. We'll talk about some hybrid scenarios here in a second. But I think one of the fear things with the cloud is that you always have to have everything in the cloud. That's not necessarily true. Now, hybrid can also mean cloud to cloud. So let's say Google to Azure or AWS to Google, or you get the idea, right? It really depends on what you're looking for here. But don't go into this saying we're either all in or we're all out. That's not necessarily how it has to be. Maybe it's what you want to do, but it's not necessarily what you have to do. But you do have those other considerations like those core infrastructure components. So what are the hybrid scenarios for SQL Server? The main one is disaster recovery. And it works very well for this. But going back to, again, I keep bringing it home to this, but it's very true because I see it all the time, is we want to do disaster recovery. We'll take an availability group or distributed availability group or log shipping, and we'll get it up to insert public cloud name here. But they don't want to put all the other infrastructure up there. Okay, so what happens if you have to switch to Azure because you had a disaster on premises? You might be able to get your SQL Server instance up or your databases up, but how is everything else going to work? What about your applications? You have to think about things like that. You could also put your data files for on-premises SQL Server up in, say, Azure Blob Store. One of the common uses I see, whether it's Amazon or Microsoft or Google, is sticking your backups up in the cloud. So when we're talking about the public cloud there, that's, cold storage. It's sometimes they have the capacity that you don't necessarily do. Plus it gets it off premises. So you're not worried about single points of failure on premises. Those backups are up in a cloud provider. Azure Arc was fairly recently introduced. You can look it up. It's basically helping you manage your SQL Server investments, and it's cloud-based. So let's talk networking here for a second, because it underlies everything, and it's one of the most fundamental things in any cloud provider. Look, it's still networking. If you're used to virtualization, you're used to the concept of a software-defined data center. Well, that's all the cloud providers really are. So in that, you would have software-defined networking. Okay? Now, what does that mean? So you have virtualized NICs, you have virtualized security, you name it, it's up in the cloud, and it's software-defined, right? You're not going and putting in a physical router, and you're not hooking up the wires. That's not what you're doing here. You're actually going and just defining all that in a software way, if you will, through an interface. We're going to look at some of this here in a moment, because a couple things are different. There's one main thing I'm going to point out to you that is actually very different. In AWS, your networking configuration is split between basically two things, Virtual Private Cloud or VPC, and Elastic Compute 2, which is basically their version of IaaS. So it's not as straightforward. Azure, there's a whole bunch of stuff. There's network security groups. You could set things at individual VMs. I'll show you a little bit of that. Google has some of that as well. So before I show you demo, there are really one more concept in terms of networking that I want to talk to you here about. First of all, there isn't magic here. You need to somehow be able to communicate from your place of business to one of these cloud providers. And you need to do it securely. I mean, you're not going to just want to hang out over the public internet and put all your mission critical servers on the internet. That's just asking for trouble. And we've all seen that over the past few years where somebody didn't, for example, secure a bucket in Amazon's storage, right? And stuff leaks. That's not where you don't want to be on the front page of the news. Bottom line. So how do you do that? Well, there's two main ways to do it. You set up a site-to-site VPN, which is a secure tunnel between point A and point B. And those pictures, by way, are from Azure's documentation. But so site-to-site, you could do it, but you're limited to whatever your internet connection is. That's both good and bad, right? Maybe you have a wonderful internet connection. It certainly might be a little bit cheaper, but maybe isn't the right thing to do. If you want basically a direct pipe from on-premises up to Azure or AWS or GCP, they all have their own direct things. You generally have to go through a telco. It's a more specialized setup. It's not going to be free, and it's certainly not going to be the cheapest thing. But in an enterprise class shop where you need to have reliable connectivity to and from your public cloud provider of choice, these are the kinds of things that you need to budget for. So again, just the concept of, we're going to go to the cloud. Well, have your infrastructure folks thought of things like this? You got to have these conversations because, and they have to happen long before you even talk about migrating things like databases and instances and extending and doing hybrid configurations. Because if this networking stuff is wrong, and I've seen it, I guarantee you things will not work properly. Now, let me give you for example. Obviously, COVID happened this year, and I've seen where on-premises, certain companies have had resources in the cloud that seem normalish. They're working on their desktops in an office. Most people, at least here in the US, are still working from home. So now you have people using VPN or accessing their stuff remotely. They're not going into the office, so you're adding a couple extra hops. Then you have the office, which then has a connection up to Azure or AWS or GCP. And then if you're querying a database up in Azure, it's got to make that round trip all the way up and down. So you've added, a couple more network segments in. So if you were slow to begin with from on-premises to public cloud or provider of choice, imagine now adding a couple more layers because people are working from home. And that affects performance. We've seen where applications become dog slow that are SQL Server related because of this. And customers have had to implement mitigations like putting app servers and Citrix and remote desktop type servers up in their cloud provider of choice to be nearer to the database server to get performance where it needed to be. So again, these are the types of things. I'm giving you real world stuff here. It just happens. All right, so let's have a look now at some networking things. Okay. So this is EC2 right here, okay? So this is Amazon's version of infrastructure as a service. The instances are your VMs. So I've got a bunch here. But really what I want to show you here is from a network perspective, where I define my IP addresses is here. So, and it's very similar in Azure. So let's reconnect here. So this is the Azure portal. So I'm going to look at my virtual machines. So I'm going to show you this inside the VM here in a moment. But here we've got some networking. Here's my virtual network interface. Okay. If I click on this, and then I look at IP configurations. Now, if I just click in here, you'll see that I have a static address defined here of 10.00.50. Okay, great. Now if I go back, close this blade, you'll notice here also, for example, I say inherit from virtual network. Okay, what does that mean? So let's go back here to the virtual machine, and then go back to networking, and then I've got this virtual network here. So here's basically where I define things like my DNS servers. So if I have a private subnet or things like that, you define that stuff here. Obviously, if I have firewall or any kind of rules, I can define things like security. Now, I talked about network security groups. So if we look here, for example, at this security group, here's where you define, I'm going to let these certain ports through. So for example, if you're going to be configuring things like distributed availability groups, you'd open up some of that stuff here, maybe. Maybe you wouldn't have to, maybe you do it elsewhere. But you get the point. This is where you define your security. You get this wrong, somebody could get into your network. The other thing I want to show you here really quickly, before I go into the VM, if I go back to the VM itself, is that, so on this DC, I've got a public IP address. Now I'm showing it, it's going to change. So, but you don't have to give things a public IP address. Think about what I said earlier. You want things to be an extension of your on-premises. That means you need to have your networking on-premises talked up here so that this would be just like if you had offices in London and Tokyo and New York and wherever else, Sydney, wherever else in the world. You know, they could talk in the same way. Azure's just essentially another data center for you, okay? Now, if we look at this, we saw that it had that IP address. But if we look at my IP configuration, okay, it's IPv4. Notice it says DHCP enabled. Well, that's because it is. I don't define that networking at all on this, on the NIC. So if I went and looked at this virtual NIC, and I went and looked at just IPv4, notice there's nothing here. This is very different than on-premises, right? We define things actually on what's there. Whereas here we kind of do it externally, same thing again in AWS. So similar concepts, but your infrastructure folks are going to have to wrap their heads around how things are different. And again, this is not something that you just wake up one morning and go do. You have to kind of figure this out, or like a lot of customers do with us, they hire us to help jumpstart them, and then obviously they own it long term. But this stuff is very hard, and there are a lot of teething pains when it comes to getting all this right. Before I move on to IaaS more formally, let me just talk about a few high-level things that sort of best practices, tips and tricks that I see, or a bit of FUD, fear, uncertainty, and doubt that I hear all the time. First of all, yes, all the public clouds, be it AWS, Azure, GCP, they're very different just by looking at those interfaces. You saw they were very different. The reality, they're more same than different because they offer a lot of the same services. Okay? depending on where you deployed, what region, what data center, what have you, depending on the cloud, obviously, you may get certain features that are available in one and not the other. So if you're looking to use something specific, you may have to stick a resource in a certain place. Yes, you still have to worry about security. Just because you put it in the cloud doesn't mean you don't have to lock it down. Think about things like data encryption and protecting your data at rest, making sure your networks are secure. All that stuff still applies. As I mentioned, most things that have happened bad as it relates to companies putting things in the cloud is largely because of bad security. You don't want to wind up, as I said, on the front page of the news. You have to sort of take care of that, and that takes time. Same thing with that exposing stuff on the internet. I showed you my VM. It has a public IP, but I'm not a corporation. I'm just sitting here recording this session at home. I'm not part of a big conglomerate that has all that stuff. So just for my little bit of testing, it's fine. But if I was doing this in a corporate environment, no way would I have something like that. And the other thing I have to say is all the public clouds, Microsoft has had outages, Amazon's had some. I'll talk to you a little bit later about when we talk about things like availability groups and availability in general, what some of this stuff means. But the reality of this is your cloud provider has availability stuff too, and we'll talk about their SLAs upcoming as well. So you need to come up with solutions. That means spreading things out over different regions, different data centers. Maybe you have a cloud-to-cloud strategy. You don't have all eggs in one basket. Either way, just because you go to a cloud, and this is managing expectations with your management, it's not going to fix all your ill wills. It just comes with a whole new set of challenges. So let's talk about infrastructure as a service. Look, laaS is just a VM. Let's focus now on infrastructure as a service for a little bit. Here's some high level, and then we're going to drill down into some of these as we go on in this section. First of all, we're talking VMs, so it's OS plus SQL Server. I'm going to compare and contrast build versus buy, but the bottom line here is if you do the buy, and you want to sort of use a prepackaged image that one of the cloud providers has for you, does it have what you need, right? That's that what images is available thing. We'll hopefully get a chance to look at that. That second bullet point I can't stress enough. Some of you are still physical, never did virtualization, now looking at the cloud. So this is going to be a harder transition for you. Those of you that have virtualization already, and you're pretty good at it, chances are you'll have higher success. If you suck at virtualization on premises, I can almost guarantee you, you're going to have a tough time in the cloud because it's not easier, and in many cases, and certainly there are less knobs. So some tricks you might have been able to do on premises to, say, performance tune, you may not have some of that stuff here. We're going to get into cost as it relates to everything, but understand that moving to one of the public cloud providers for IaaS may or may not be cheaper. There are just some architectures which may not be natural fits. Okay, I mentioned build versus buy. Now, build basically is you have an ISO image that you go build something in the cloud, save it as like a template, and you configure it exactly the way you want it to be as best you can given any kind of conditions that will come in from a cloud provider that you could or couldn't do. Buy means that you're taking a pre-existing image that they have of, let's say, Windows Server 2019 with SQL Server 2019 and just deploying that. You're configuring a couple of things, but that's really about it. It may or may not work for you. Now, what do I mean by that? Okay, this is what I mean by that. So let's just create. I'm not going to go through through all of it, but I'm just going to show you sort of what I mean here. So let's create a new virtual machine. This is Azure, but they're all similar in that they have images with Windows and SQL Server. So I'm going to just kind of, let's call this pass demo VM. So I don't want this. There are multiple ways you can go at this problem. That's the other problem of the cloud. I mistyped something there. Okay. So you see here, for example, SQL Server 2019 web, blah, 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 blah. So here's standard. Now there are images with and without everything. So if it doesn't say database engine only, it's literally the kitchen sink. So let's say I want to do SQL Server 2019 standard. That's great. Okay. So let's do this. My super secure password. Now you can script all this as well. I mean, I'm just showing you in the GUI because I kind of want to show you some of the options you have during configuration. Okay, we're not going to talk about licensing just yet. So let's get disks. This is for my OS disk. This isn't for SQL Server. We're going to get into SQL Server here in a moment. Now here, for example, I can't choose the name of what my virtual NIC card is going to be. This is where kind of doing things on your own gets to be a little better. Now I can select which network I want to use and which subnet. Do I want a public IP or not? You know, do I have an existing, you know, network security group? Things like that, right? Now, do I want to, for example, if you're just clicking next, next, next and not looking, it's going to automatically do this. Or you set to manual out of the box. And here, just to skip advanced here for a second. So this is basically all you have is knobs. So you could do automated backups. It's going to do automated patching unless you disable it. You can change your disk configuration, which we'll talk about in a little bit. Do you want to use SQL Auth? You know, now these are, the other thing you can't do here is you can't join this to a domain using this. There are other ways to do it. You could do it afterwards, but not as part of this. So even if you have an existing domain, there's no way in this wizard to do that. Change your port, and you get the idea here, right? It's not the most flexible thing. Plus, you notice it says SQL Server 2019, Windows Server 2019. It didn't give you a build number. It's just whatever their latest build is. So if you have certain build standards, that's not going to work for you. You have to really think these kinds of things through. Now, if you're using VMware on premises, there is actually vSphere in the cloud. All of them have it, actually. So if you don't want to spin up an IaaS VM and basically you want to extend your on-premises data center, or you don't want to manage VMware on-premises anymore and want to just move things to the cloud, well, you can take your VMware VMs and wholesale move them up there. So those are the offerings. They all have it. But you're also not doing cloud-native stuff. You're basically just using an implementation of vSphere. Well, not basically. You are using an implementation of vSphere up in the cloud. You know, will it get you to a cloud sooner? Maybe, but is it the right thing to do? I don't know. You'd have to tell me. I'm not running things in your environment. With licensing, you can either bring your own license, BYOL, or you can basically, if you're doing that wizard there, as you can see, you basically, it will give you the license as part of your pricing. Is that something you want to do? Who has to control costs? You need to have all these conversations with folks. This isn't necessarily like what you even do with on-premises virtualization in some cases. You're basically licensing per thing here. So you have to be, you know, pretty judicious and look at what's going on. The takeaway I want you to have here from the comparisons between Amazon, Microsoft, and Google is that they have different kinds of VMs. They have ones that are more geared if you're CPU bound or if you're memory bound and you want to have more memory optimized, for example. They all don't have the same things, but they all have similar things, as you can see here. And this is where you have to know your workload. And we're going to talk about some of that here upcoming in a few moments. But if you don't know this stuff, you're basically throwing a dart at a dartboard to try and figure out which VM is right for you. Disks also are both good and bad up in the cloud. Now, sometimes, on premises you're gated for certain things and certain limitations are there. In a public cloud, maybe some of those are removed, but you have other chains. Like understanding your limits of your VM and the size of disk you choose to see what kind of performance you're going to get. There are different kinds of disks. There's, more premium disks that are faster. Every cloud provider will call them something different. There's more basic disks. There's the equivalent of spinning rust or hard disks. Most of the clouds have the concept of a temporary or an ephemeral disk. Now that disk, when you reboot the server, wipes everything on it. So don't put SQL Server on there. There was a case on the SQL Help hashtag recently where someone was trying to migrate to Azure and they were using Drive D for some stuff. So that wound up going on what was that ephemeral drive. And when they rebooted, it got blown away and SQL Server no longer worked. So part of this is figuring out your drive configurations too, right? So let's have a look at some of this stuff in the other clouds. Where I want to start is with the VMs themselves. Now with virtual machines, you can have different VM sizes. And obviously there's memory, compute, whatever. But let's look at memory optimized here for a moment. Here's where you have to know what you need, okay? Because these here, for example, they tell you they're running on these types of Xeon processors, or what types of things and what's potentially enabled on the processor, things like that. These are AMD, these are Intel, these ones are Intel. You could look up these processor specs, much like you would if you're deploying on premises on physical, not virtual, and see what's right for you. Now, here's what you need to understand. So let's look at, say, the ESV3. Let's look at these, okay? Here's what I want to point out. And again, every single variant of all this stuff is going to be slightly different, but this is concepts. You can't configure, let's just say, 3 vCPUs like you could on VMware back on premises. These are fixed sizes. So if you need 48 gig of memory, you're getting this VM. Now, this is that temporary ephemeral storage. The thing about the temporary / ephemeral storage is that it's generally fast, doesn't count against any other limits. But it's not the kind of thing, again, you want to rely on. Maybe you can put temp DB there. Maybe. A lot of our customers can't, and they wind up using premium disks in Azure. Just because of sheer sizes. Because the only way to get bigger and faster is to size up your VM, as you can see. Now, the bigger things you need to worry about are things like your disks and things like bandwidth and how you're gated. So at the VM layer, and all of the providers have similar concepts, you're gated by how many megabytes per second and IOPS you could ultimately do. It doesn't matter if you have 1 disk or 16. That's everything. That's the temp bandwidth. But you're still gated completely on your, I think it's because I made this too big. It is. Okay. So these are a better example. Sorry about that. So I'm going to scroll over. So this is the E2SV3. Similar things. Again, if you need a lot of disks, I have customers that have standards the way they deploy things, and they use like 25, 30 disks. They'd have to automatically step up to something like this. So there's the temp storage, but if we look at throughput for IOPS, depending on whether you're using burst or whatever, you see it goes up by the size. Same thing with bandwidth, but you notice it caps out at some point. Like at some point it doesn't get really faster. So if you need to exceed any one of these limits, here's where you look at this and reasonably go, maybe my workload needs to stay on premises. Now also understand that the bigger the VM, the more cost there is. So if you need certain, like if you're not memory constrained and you only need 128 gig of memory, but you need a ton of IOPS like this, you're going to wind up buying this bigger VM just for that. Again, you can't, there are no sliders to say more memory, less disk, nope, none of that. So that's what makes this hard, because what we've seen with our customers is you hit a wall of performance at some point, and you basically have to resize it or tune your workload or do something to reduce IOPS. Maybe it's adding more memory, getting a thing with a bigger memory slightly that reduces your IOPS and that gets you back under the cap. There's a whole ton of stuff. Now, if we look at Amazon, again, not surprisingly, we're going to see very similar things. You know, depending what size, megs per second for on storage and network, and so this is capacity planning in a whole different way. And this is kind of why I said, if you suck at virtualization on premises, you're going to suck at this in the cloud, because really what this boils down to successfully migrate is you need to have good baseline and benchmark understanding of your applications and SQL Server performance to pick the right things up in the public cloud. There is this good picture. This is actually Linux documentation, but that kind of talks about how the VM gates you, and you know, you could even have really fast disks, but if you're gated by your VM, it all factors in. So you have to be really careful on how you pick things up in the cloud, okay? The other thing that I want to say is, if you're buying premium disks in general, you're going to pay for that storage even if the VMs are shut down. And by the way, while we're talking about shutdown, I'm just going to show it to you in Azure, and it's largely the same way in EC2. So if I go to my VMs, and let's just say I pick this one, I'm not going to actually do it. But if I just hit, if I shut it down inside the guest, you're still going to incur like full cost. You physically have to stop it at the Azure level to deallocate it, to not incur compute costs that are of like a running VM. So understand that, again, that's different, right? On premises, we didn't have to worry about things like that. Okay. So let's talk about PaaS here now. PaaS is more limited than IaaS. This is basically, you get something like a database like Azure here, Azure SQL Database, and that's all you get to manage. You know, you don't get a full instance of SQL Server. There's no physical server or virtual server for you to manage. You're measuring performance in vCores or DTUs, and that's it. You know, you're not going to get a whole ton of other stuff that you can do. And that may be perfect. Like if you have a web-based application and you don't need a whole SQL Server installation, you just need access to data. This might be great. But understand that you have no control over things like versioning. You don't have control over when they update. So if they break your query because of something they did on the back end, you've got to fix your app. There's no kind of necessary rollback here. That's, again, the better view of the world in the cloud because it's just agile. Your database is up there. You're not managing a whole bunch of stuff. But now you have to make sure that when they roll out changes, things don't break you. Now there's managed instance, which kind of looks and feels like a normal instance of SQL Server, but you don't get everything. We're going to talk a little bit later when we talk about migration, about data and how to get things in and out, or how you can and can't in some cases. But again, similar to Azure SQL Database, you don't control the version that's for managed instance. It's not traditional SQL Server in that sense. So you have to be really careful here and test thoroughly. I know people who've tried managed instance, didn't work. I know people who use managed instance and love it. So you have to be really careful here and test these things out. In Amazon with RDS, it is basically an instance of SQL Server. You can use things like traditional backups, but you don't get to control the server. So all these things are basically about presenting SQL Server to you or databases to you in a way that you're not managing things, which is easier for some, but maybe hard for others. You still have to worry about obviously encrypting your data and stuff, and all the availability is kind of built into these platforms. So you basically click a couple of buttons and it configures it for you. You can't choose, well, in this one I want to do log shipping, this one I want to do this one I want to do that. Not happening on any of this stuff. And Cloud SQL for SQL Server is Google Cloud's version of all this stuff. You get the picture, right? Okay, so how do you get to the cloud? How do you migrate from on-premises or some other cloud, or even cloud to cloud? I want to go from AWS to Azure. Well, it's migration. It's what we do. There's no magic here. Backup, copy, and restore. In some cases, log shipping, distributed availability groups if you're on 2016 Enterprise Edition or later. With Enterprise Edition, that's not a standard feature. But that doesn't work in all cases. That would work for IaaS, but with PaaS, and we're going to talk about that here in a moment, that's a little bit different. How fast? That's always the hardest one, is how long is this going to take? Well, think about moving to another data center or setting up your DR today. Getting from New York to California or London to Tokyo takes a while to copy a multi-terabyte database. Maybe you have to fly it around somewhere or send it on a USB thing, whatever. But the reality is network bandwidth is going to hurt you here. How you've configured your, say, IaaS VM in this case. Now, with PaaS, meaning Azure SQL Database, RDS, Azure SQL Managed Instance, on the Azure options, you can't really, and there's a little bit of an exception with Managed Instance, but for the most part, take a database and from on-premises SQL Server and restore it to the cloud. And you certainly can't take a backup from one of those and get it to an IaaS or back on premises. So that's something you need to think about here, and then we'll talk about that here in a second. Now with RDS, you can use traditional backups if they're copied to Amazon's, storage stuff. But again, you're going through a lot of hoops. And in the case of an Azure, for example, let's just take managed instance and to that next point there. Do you ever want or need to go back or flow the other way? Let's say you've been working for 3 months in managed instance, and for whatever reason, it didn't work for you. How do you get back to on-premises or to IaaS? Well, you can't take a backup and restore it from there to an instance of SQL Server. So you've got some find a way to export your data and get it there. So this is why you had to test. This is why you had to make sure that it's going to work for you, because some things are a one-way street. Now, we have customers who in some cases don't want to go all in on the cloud. They want most of their stuff up there, but maybe they want some stuff on premises. Or maybe on premises becomes now DR. Like, what if one of the cloud providers goes out? Well, you can go back the other way, but you're going to pay for the egress of the stuff flowing out. The other thing here too, and this goes back to what I showed you earlier with the builds of SQL Server, and we'll talk about PaaS here in a moment. But your third-party apps, we see this problem. This is the age-old problem of vendor X won't support this version of SQL Server, this CU, or this service pack if it's an older version, whatever. The cloud is no different. So if you go deploy one of those pre-built VMs, or are they going to support you? Or if you're using Azure SQL Database, even if you put it in a database compatibility level, are they going to support you? You need to know these things. Don't just go do this stuff and then find out after the fact, because it's painful in some cases to go back. So let's talk about administration here, okay? It's still SQL Server, so you still have to worry about, we talked about security, but backups. We'll talk about that here in a moment in availability. But monitoring, much like virtualization, you can look at stuff if you're using IaaS, what's going on in guest, but you don't have a lot of visibility at the EC2, GCP, Azure layer to see what's going on for performance. So if you have performance issues, you basically need two layers of monitoring, something to figure out what's going on in Azure, something to figure out what's going on in the VM and coordinate all this stuff. It's a little bit more of a black box than if you had the physical server, right? You also need to be able to measure how things are changing over time. Are you going to have to maybe resize a VM? Are you trending up where your IOPS are going up, that if you don't get it, all of a sudden your performance is going to tank because you hit the ceiling, right? It's these kinds of things that you now have to worry about in a cloud environment that you generally didn't have to worry about on premises. Patching, you saw from the UI there, maybe you'll let Microsoft do it, maybe you'll do it on your own. Is it automated? Are you going to have it manual? But the thing that I want to address here specifically is when your cloud provider of choice decides to patch the underlying hosts, it may not be 100% transparent. We have a customer where their workload's very sensitive and they're using availability groups, and we had to adjust some settings to be able to hopefully mitigate that, because it's largely transparent and most customers don't get affected, but we saw some blips, so we had to change some thresholds, whatever. Just understand that when they patch their underlying servers and move your hosts for your VM, if you're using IaaS, you need to account for that. A few other really quick things before we move on to availability. First of all, I can tell you as somebody who's been doing this for a while, just let's take Azure for a second. That portal has changed a lot. You may wake up one day and it looks completely different. So what's your plan for keeping up with how your public cloud provider of choice is changing? Are you going to have multiple sets of skills, some for on-premises, some for the cloud? It's a lot to manage. You need to come up with a plan of how you're going to do that. Your company's going to have to implement some kind of cost control, as well as managing things like performance expectations. That's the politics of this, because I guarantee you at some point in the not-so-distant future, if this hasn't already happened to you, that whoever's paying for your cloud resources is going to wake up, look at the bill, and say, what? It can get expensive. So you just don't want people be able to spin up the biggest VM. That might be entrusted to a few people. Use role-based or access control, or RBAC, to control that kind of stuff. They all have that concept. Managing performance expectations, availability expectations, all that kind of stuff. The cloud, for example, doesn't give you necessarily any better or worse availability than on-premises in some cases. In other cases, it absolutely does, but it doesn't fix all your availability problems just by shifting to the cloud. We've talked about security already, but it's important enough that I wanted to mention it again. Let's talk about a topic near and dear to my heart, availability. With IaaS, since it's a VM, and with an OS and SQL Server, you have everything that's available to you. Availability groups, failover cluster instances, log shipping, you name it, it's there. There's some platform level things that we'll talk about. PaaS is all platform. You basically click a few buttons or run a PowerShell script, and you don't have a lot of options like you do in Guest. It still boils down to RTO and RPO and the very fundamentals of how long do you have to get back up running and how much data you can afford to lose. And that will help you choose whether you use maybe a platform-based option or something in Guest or a combination thereof. When it comes to clustered configurations of SQL Server, talking AGs and FCIs here, just a few quick high-level things to consider. First of all, if you need to connect to it, you need to worry about things like the ILB in Azure, or where you're configuring that shared IP address. That's what both of those things handle with. There's the distributed network name now in Azure, and with Windows that works for some configurations but not all. These are the considerations. So it's slightly different than on-premises. Like, you wouldn't necessarily use a distributed network name on-premises, but in the cloud it may make certain things easier. Where are you putting that witness resource? So I can do a cloud witness, file share witness, maybe somewhere else. Where are you putting that stoneth for pacemaker if using Linux? I talked about that maintenance you can't control and the threshold already. But like I said, we saw that. It affected an availability group. We had failovers from one replica to another because of this. And we had to up our, same subnet threshold and cross subnet thresholds to tolerate this, because the outages we saw due to Microsoft's maintenance were a little above 30, most were around 30 seconds. So we upped some of those values. How you can do shared storage if you want to do a failover cluster instance. The best option right now is shared disks in Azure. Everything else, to be honest with you, just kind of sucks. There's third-party stuff like Sios Datakeeper, which is actually pretty good. But again, it's third-party, but fully supported. So you need to, again, think about this. Personally, don't love FCIs in the cloud, but if you want to do it, fine. This is the one thing you absolutely have to get right, which is your backups. If you don't, all the other stuff doesn't matter. Even with PaaS, and even if Microsoft or Amazon or whatever is handling it for you, just make sure that it meets your RTOs and RPOs. For IaaS, it's much like a VM on premises. Are you going to back up the VM? Well, you need to make sure that it's not going to interfere. Let's say you're running an availability group. I've seen it affect it when it does the freeze and thaw, because it's doing application consistent backup, that it affects the performance of the availability group, so we have to unconfigure that. So you have to think about things like that. Are you going to back up just the databases? Are you going to do it in the guest and copy it off somewhere? Are you going to do it direct to Azure Blob Storage or Amazon's Elastic Block stuff, S3? A bunch of stuff you need to think about. What's your long-term strategy? What's your retention? It's all sort of the same as doing it on premises, just up in a public cloud. All of the public clouds have the concept of where you place your VM. There are regions around the world. So if you want to, for example, set up DR, you could have stuff in, say, East Coast US and West Coast US, or East Coast US and Canada if you're going internationally, whatever have you, right? Now, there are the concept of zones within those regions, meaning those are usually physically separate. They usually define those as physically separate data centers. So you may be introducing a little bit of latency, but you get better availability within a region. And Azure also has availability sets, which is basically like making sure things are split across racks, and you have update domains so that if Microsoft is doing said maintenance, like if all your VMs were staying on a single host, they would be affected, but it places them so that that wouldn't be the case. So you'd want to split up, say, your availability group replicas over a couple different things in the availability set, so it'll be fine. But again, you have to think about that, right? And a lot of these things, especially this where you set this stuff up, that's done when you configure these VMs. You generally can't retrofit this stuff, so you have to think about it ahead of time. For PaaS, I mean, again, not much here. For RDS, it's AGs behind the scenes. There are auto failover groups and active geo-replication for the Azure stuff, but again, there's not a lot of choice here. And because you don't have traditional backup and restore, it's not like you can do log shipping to these things or from these things. So you have to really think about this. Honestly, it's not set and forget or a no-brainer. You have to think about, does this work for me? Does this work for our availability strategy? The last thing I want to talk about before we move on to summarize and open up the floor for questions is this. Now, I've had this conversation with more than one customer, which is why I'm sort of showing it to you here. RTOs and RPOs are service level agreements. But what I want you to understand here is that, so let's just look at virtual machines, these SLA things here. Notice, for example, I'm going to zoom in here. So, legal, okay? These are not soft things. This is legal documentation. And you can get into it. And this is everything that Microsoft guarantees. And if there are penalties thereof. So this is, I mean, a legal document. When you create stuff in Azure, this is what you're saying. So for example, monthly uptime. If they go below 4 nines, they'll give you 10% service credit. So that little blip my customer saw, that they saw about a minute of downtime, that would never be affected by this. So, yeah, this is unfortunate. But this is what you need to think about of when you see these little blips, you see these other things. You need to understand what these services are guaranteeing you or not guaranteeing you, as the case may be. To sum things up, I threw a lot at you here, but the cloud is a lot like on-premises, but going to a public cloud is also very much not like on-premises. It's not set and forget. Please, I implore you, just don't move things the way they are on-premises. Try and do some optimization. Think about what you're doing. You have to really understand your workloads to size properly. Otherwise, you're going to either undersize and then pay a lot of money to make it right, or, you know, you're going to oversize and spend too much money. It can go both ways there. Your skills are applicable, which is good, and, you know, everything you care about is the same, but you're going to have to change your mindset on some of this stuff. And with that, we'll open the floor to questions. I want to thank you for attending this session, and I hope you have a good rest of Summit, and hope you stay well. Let's take some questions.